Okay, recording for 5-2, day 2 in advanced math. These notes will go kind of quick because I do not have a whole lot of time to make them. So please feel free to pause the recording at any time that you need to. So take some time right now to do the warm-up, and then please pause it so that you have plenty of time to do that, and then continue playing it once you have it completed. Arc length, remember, is S equals R times theta. And so if we have arc length equals a radius of 5 times theta, remember theta does have to be in radians, and so you would take 38 degrees over 1, which would be times then pi over 180 degrees. Degrees would cancel, remember. In essence, you can just put the 38 pi over 180 right on in there, and you can multiply that out, and it comes out approximately to 3.32 centimeters. And remember, at 38 degrees, the arc length is probably going to be less than the radius, because it's at 1 radian where they are actually equal. And remember, arc length is basically saying, like if you looked at this picture, would just be the length of that. And that's what they were wondering about for arc length. Area of the sector is actually asking for all of that. Well, basically, what piece of the pie do you have? And a sector is basically just a, you could talk of it as a slice of the circle or a slice of the pie. A few formulas that you're going to want to know and need throughout the homework. The area of a circle is pi r squared. Circumference is pi times diameter, or you can say 2 pi r. And the area of a sector, this would be the new one for you, 1/2 r squared theta. Once again, theta does have to be the radian measure. That will give you the area of just that small piece of the pie. And then example 1 says, determine the area of the sector if an angle is 0.95. Well, that's radians because there is no degree symbol there. And the arc length is 16. Well, I know area is now 1/2 r squared theta for that, and it tells me arc length though, because if I try and fill this in, I've got 1/2. I don't know r, but I do know theta is 0.95. So we have to go and find the radius, which means we have to use the other formula, which is right there, because we know the arc length is 16. We don't know r, but we do know this is 0.95. So you divide by 0.95. Again, this is so that we can get the radius. Okay? And you find out the radius is approximately 16.84. Or you could just basically, if you wanted to, you could use that decimal of 16.84, or what you could do, depending on how good you are with the calculator, is just take 16 divided by 0.95 and put it in the blank. I'll accept it either way. So you put 16.84 in here, and then you take a look, you plug it in. The area is approximately 134.7 centimeters squared, because you took centimeters times centimeters. So this one here says determine the area of the sector if the central angle is 45 degrees and the radius is 5. So once again, we can go to this formula and just kind of fill it in as best you can. Well, we know the radius is 5. Well, that's good. So we got to square that. But again, theta has to be radian. So we got to change 45 degrees. And again, you're going to want degrees on the bottom. And remember, pi over 180 is just the form of 1 for the unit circle. It's one of the options we have, and probably the easiest one to work with. And again, we could simplify. You don't have to, but this becomes a 1, that becomes a 4. So it's basically just pi over 4. So you're seeing the various ways that I can try and, keep you off guard with these problems. I can give you various information. And if we round this one, let's say we'll go to the nearest hundredth this time, 9.82 units. squared. Again, watch your labels. They're going to be very important. And keep in mind, I am going fast with this because I am limited with my time. So you can pause at any time to get more information. Or you can replay it if need be. So here, the area of the sector, if the angle is 1.25, again, that's radians, and the arc length is 12. All right, well, fill in as much as you can. 1/2. Don't know r again. And theta we know is 1.25. So this is very similar to the first one. And so what you might want to do is try and solve this one on your own. So maybe pause it, solve it on your own, and then play it some more. Because what we do have to do is go to the arc length formula. And so we put a 12 here because that's what the arc length is. Don't know r, but I know that's 1.25. To solve that, we will, as you can tell, divide by 1.25. And so r is, well, right on 9.6. That's what that ends up being. And so then you bring this over here. So 1/2, you put 9.6 in for the radius. You square it, you take it times 1.25, and the area is 57.6 square centimeters. Okay. I hope that was not too fast, but please feel free to play it again. Or again, pause it, go back, whatever it is that you need to do. And the assignment is page 252, 28 through 38, 51, and 54.